Did you know space holds secrets your textbooks never told you? Think about everything you learned in school, the planets, the stars, maybe even a little about black holes. But what if I told you there's so much more lurking out there, waiting to shatter everything you thought you knew? The universe is wilder, weirder, and more wonderful than any classroom could ever prepare you for. Picture this: hidden oceans beneath icy moons, stars that dance around invisible monsters, and galaxies so vast they make our Milky Way look like a speck of dust. These aren't sci-fi fantasies, they're real, mind-bending truths about the cosmos. And today, we're diving into 20 of the most astonishing space facts you definitely didn't learn in school. Let's start with a question that'll twist your brain. What if I told you there's a planet where it rains glass sideways, or that some black holes sing? These aren't just random trivia, they're glimpses into how utterly bizarre and beautiful the universe truly is. Schools focus on the basics, and that's fine, but the real magic happens in the details they skip. Imagine standing on a moon where the sky is permanently split between day and night, or discovering a place where diamonds fall like rain. These aren't just cool facts, they're invitations to rethink everything we assume about space. And the craziest part, scientists are uncovering new mysteries like these every single day. So why stick to the ordinary when the extraordinary is out there? This video isn't just a list of facts, it's a journey into the unknown, a chance to see the cosmos through fresh eyes. We'll explore alien oceans that could harbor life, unravel the secrets of rogue planets drifting through the void, and even peek into the heart of a star's explosive death. By the time we're done, you'll see space not as a static picture in a textbook, but as a living, breathing enigma, one that's constantly surprising us. Ready to have your mind blown? Let's go. The moon may seem like a constant, unchanging companion in our night sky, but here's something your science teacher probably never mentioned. It's actually sneaking away from us. Every single year, the moon drifts about 3.8 centimeters farther into space, all thanks to the tug of war between Earth's gravity and the moon's pull on our oceans. Think of it like a cosmic dance where the moon's gravity drags our tides forward, and that energy pushes the moon just a tiny bit farther out. It doesn't sound like much, but over time, this adds up in ways that'll change Earth in ways we can barely imagine. Picture this: in about 600 million years, the moon will be too far away to fully cover the sun during an eclipse. Those breathtaking total solar eclipses where day turns to night and the sun's corona flares into view. They'll be a thing of the past. Instead, we'll only get ring-shaped annular eclipses where the moon is too small in the sky to block the sun completely. And that's not all. As the moon retreats, Earth's rotation will slow down, stretching our days longer. Right now, a day is 24 hours, but back when dinosaurs roamed, it was closer to 23. In the distant future, days could last 25 hours or more. But here's the wildest part: the moon wasn't always this far away. Scientists believe it formed when a Mars-sized object slammed into early Earth, flinging debris into orbit that eventually clumped together into our moon. Back then, it was 10 times closer, looming huge in the sky and causing massive tides that raced across the planet. Over billions of years, it's been inching outward, reshaping our planet's rhythm as it goes. So next time you gaze up at the moon, remember, it's not just hanging there, it's slowly saying goodbye, one gentle nudge at a time. If Earth's spin suddenly reversed, you'd see the sun rise in the west and set in the east, but on Venus, that exact backward dance is just another day in its utterly alien rhythm. While every other planet in our solar system spins counterclockwise, Venus defiantly rotates clockwise, making it the only planet with a true retrograde rotation. Imagine standing on its scorching surface. If you could survive the 900-degree heat and crushing atmospheric pressure, you'd witness a sunrise that takes 117 Earth days to crawl across the sky, only to set another 117 days later. Even weirder, a full Venusian day lasts longer than its year. So how did Venus end up spinning backward? Scientists have two leading theories, and both sound like cosmic catastrophes. The first suggests a colossal collision similar to the impact that created our moon. But instead of forming a companion, this smash-up might have sent Venus into a gravitational tumble, flipping its rotation entirely. The second theory blames the planet's soupy, supercharged atmosphere. With winds howling at hurricane speeds and air so thick it behaves like liquid, Venus' atmosphere may have dragged against the surface over billions of years, gradually slowing and reversing its spin like a stalled motor grinding into reverse. But here's what really bends the mind. Venus' backward spin creates a sky where the stars move in reverse, where compasses would point south, and where time itself feels stretched beyond recognition. While Earth's 24-hour cycle drives our rhythms of life, Venus' sluggish rotation means its mountains and valleys experience sunlight for months on end, baking under an unrelenting glare before plunging into equally long nights. It's a world where direction and duration lose all earthly meaning, proving just how strange the rules of physics can get when applied beyond our familiar blue marble. And yet, Venus isn't entirely alone in its defiance. Uranus also bucks the trend, spinning on its side like a tipped-over rolling pin, likely from another ancient collision. But Venus remains the solar system's true rebel, a planet that didn't just tilt off kilter but flipped the script entirely. Next time you hear someone call Venus Earth's twin, remember, this world is anything but familiar. It's a swirling, backward enigma wrapped in acid clouds, a reminder that even in our cosmic neighborhood, normality is just a matter of perspective. Jupiter's great red spot isn't just a storm, it's a centuries-old maelstrom that could swallow Earth whole, and yet this titanic tempest is quietly wasting away before our eyes. First observed in the 1600s, this swirling crimson vortex has raged non-stop for at least 400 years. A hurricane so vast early astronomers mistook it for a solid feature on Jupiter's face. At its peak, it stretched 25,000 miles across, wide enough to fit 3 Earths side by side with room to spare. But recent measurements reveal something startling. The storm is shrinking faster than anyone predicted, collapsing inward like a deflating balloon. Just 40 years ago, the Great Red Spot could still engulf 2 Earths. Today, it barely holds one. High-speed winds that once screamed at 430 miles per hour are weakening, and the storm's iconic clay-red hue is fading to a pale salmon. Some scientists speculate it could vanish entirely within our lifetimes, a possibility that seemed unthinkable when Voyager snapped its first close-ups in 1979. Others argue it might stabilize, shrinking down to a more compact but equally ferocious system. The truth is, we've never witnessed the birth or death of a storm like this, so Jupiter is writing the rulebook in real time. What makes this vanishing act even stranger? Storms on Jupiter aren't supposed to die. Unlike Earth's hurricanes, which fizzle out within weeks when they hit land or cold water, Jupiter's Great Red Spot is an engine that feeds on itself, a self-sustaining monster with no surface to disrupt it. It draws energy from swirling gases beneath and should technically last forever. So why the sudden decline? One theory points to mysterious blades and flakes seen peeling off the storm's edges like fragments of a crumbling continent. Another suggests smaller vortices circling Jupiter might be stealing its momentum, slowly strangling the giant. Imagine standing on Jupiter's cloud tops if its crushing gravity didn't flatten you first. The storm would fill half your sky, a churning canyon of ammonia-rich winds deeper than Earth's oceans. Those fading red clouds, they likely get their color from chemicals being dragged up from Jupiter's hidden depths, meaning the color change hints at shifts happening far below. If the spot vanishes, we'll lose more than a pretty feature. We'll lose a window into Jupiter's secret weather systems, systems that have operated non-stop since the solar system was young. Here's the cosmic irony. just as our telescopes grow powerful enough to study the great red spot in microscopic detail, it might be exiting stage left. Future missions like the European Space Agency's Jupiter Icy Moons Explorer could arrive in 2031 to find only a pale scar where the storm once roared. Whether it shrinks to a dot or winks out entirely, one thing's certain: we're witnessing the end of an era, the last gasp of a solar system icon that watched over the gas giant since before telescopes existed. And when it's gone, Jupiter will still be a world of storms, but without its crimson crown, it'll feel like a sky without stars. Deep in the constellation Cancer, a planet shimmers with a secret that sounds ripped from a pirate's treasure map. Its core is a diamond the size of Earth. Meet 55 Cancri E, a world where the phrase "diamonds are forever" takes on a terrifying new meaning. This exoplanet orbits so close to its host star that a single year lasts just 18 hours, and surface temperatures rocket past 4,000 degrees Fahrenheit, hot enough to vaporize iron. Yet beneath its molten lava oceans lies a core packed with crystallized carbon, a diamond layer so massive it outweighs our entire planet 3 times over. Forget mining for gems. This is a place where diamonds aren't rare, they're the very foundation of the world itself. How did scientists uncover this glittering mystery? 55 Cancri E belongs to a rare class of carbon-rich exoplanets, worlds where oxygen is scarce and carbon dominates the chemistry. By analyzing the planet's density and comparing it to its parent star's composition, researchers realized it couldn't be made of rock and metal like Earth. Instead, the crushing pressures and infernal heat likely transformed its carbon into a dense lattice of diamond, with graphite and other exotic forms of carbon swirling in its magma seas. Picture an endless black sand beach, except the sand is pulverized diamond dust and the waves are rivers of liquid carbon. But here's what makes this planet truly bizarre: its geology defies every rule we know. On Earth, diamond forms deep underground under immense pressure, but it's still just a tiny fraction of our planet's makeup. On 55 Cancri E, diamonds aren't hidden, they're the bedrock. Some models suggest the planet's dark, glossy surface might even reflect starlight like a cosmic disco ball, glittering as it whips around its sun at breakneck speed. And if you could stand on its surface, assuming you didn't instantly melt or suffocate in its carbon monoxide atmosphere, the sky would loom with a bloated red sun 20 times larger than our own, casting eerie shadows across a landscape where mountains might literally be made of solid gemstone. Yet this diamond world isn't just a cosmic curiosity, it's rewriting the rules of planet formation. Most rocky planets like Earth or Mars are built from silicon and oxygen. But 55 Cancri E proves there's another path. Carbon-rich worlds where life as we know it couldn't exist, but where the chemistry is spectacularly alien. It's a reminder that the universe doesn't just recycle the same ingredients, it cooks up wild new recipes, turning carbon into kingdoms we're only beginning to imagine. So next time you admire a diamond ring, think bigger. Out there, a whole world spins where those sparkling stones aren't jewels, they're the pavement, the mountains, the bones of a planet that turned carbon into a glittering hellscape. And who knows, if 55 Cancri E exists, there might be others out there even stranger, waiting to prove once again that reality will always outshine fiction. Neptune shouldn't be this hot, floating at the edge of the solar system where sunlight is 900 times dimmer than on Earth. This icy giant should be a frozen, dormant world. Yet something inside Neptune is burning literally. The planet radiates 2.6 times more heat than it absorbs from the sun, a mystery that defies every textbook explanation. Picture a freezer that somehow pumps out scorching air while sitting in a blizzard. That's Neptune, a cosmic contradiction wrapped in swirling blue clouds. So where does all this heat come from? The leading theory points to Neptune's tumultuous birth. When the planet formed 4.5 billion years ago, gravitational forces likely compressed its core with unimaginable pressure, heating it like a diamond anvil. But unlike Earth, where heat slowly escapes through volcanoes or tectonic shifts, Neptune's interior remains sealed beneath crushing layers of hydrogen, helium, and supersonic water, a bizarre state where water molecules break apart into a soup of charged particles. This trapped heat might still be leaking out, driving the planet's violent weather systems. And oh, what weather it is! Neptune's winds scream at 1,300 miles per hour faster than the speed of sound on Earth, whipping up storms the size of continents. Its most famous tempest, the Great Dark Spot, vanished in the 1990s, only for new ones to erupt years later, proving this world's turbulence never sleeps. The heat bubbling up from below likely fuels these maelstroms, creating jet streams and vortices that dance across the planet's atmosphere like fire on oil. But here's the twist: Neptune isn't alone in this anomaly. Its twin, Uranus, orbits at a similar distance and should behave the same way, yet it barely emits any excess heat. This cosmic sibling rivalry has scientists baffled. Some speculate Uranus suffered a cataclysmic impact that scattered its internal heat, while Neptune's core remained intact, simmering like a forgotten stove. Others suggest Neptune's heat comes from radioactive decay deep within its mantle, or even the slow contraction of the planet itself, squeezing energy out like a cosmic stress ball. The truth might lie in Neptune's secret layers. Beneath its blue veil, the planet could harbor raining diamonds, carbon crushed into gems by the atmosphere's pressure, sinking toward the core and releasing gravitational energy as they fall. It's a world where the sky could literally be showering jewels, and those gems might hold the key to the planet's fiery heart. Until we send a probe through Neptune's storm-racked skies, this enigma will keep burning. But one thing's certain: this isn't some quiet, frozen outpost. Neptune is a cauldron of hidden fire, a reminder that even in the solar system's darkest corners, nature still has surprises up its sleeve. The sun seems like it should follow a simple rule: the closer you get to its fiery heart, the hotter it becomes. But nature loves a good paradox, and here's one that's baffled scientists for decades. The sun's wispy outer atmosphere, called the corona, is actually hundreds of times hotter than its surface. While the visible surface simmers at around 5,500 degrees Celsius, the corona blazes at over 1 million degrees. A temperature spike so extreme it's like stepping away from a campfire and suddenly feeling your skin blister from invisible flames. This is the coronal heating problem, one of the biggest unsolved mysteries in solar physics, and cracking it could rewrite everything we know about stars. So how does this cosmic oven work backward? The surface of the sun is a roiling sea of plasma, where convection currents carry heat upward like boiling water in a pot. But instead of cooling as it rises into the corona, the plasma somehow gets supercharged to unimaginable temperatures. One leading theory points to nanoflares, countless tiny explosions popping like cosmic popcorn across the sun's surface. Each one releases a burst of energy, and together, they might pump enough heat into the corona to explain its feverish state. Another idea involves magnetic fields twisting and snapping like rubber bands, creating waves that transfer energy into the corona like a whip cracking through the solar atmosphere. The consequences of this superheated halo reach far beyond the sun. The corona is the birthplace of the solar wind, a relentless stream of charged particles racing outward at nearly 1 million miles per hour. Without the corona's extreme heat, this wind wouldn't have the energy to escape the sun's gravity, meaning Earth would be bombarded by far less radiation, but we'd also miss out on the auroras that dance at our poles. The corona's heat even shapes the solar system's destiny, eroding atmospheres on planets like Mars over billions of years and determining where the protective bubble of our heliosphere ends. Here's the kicker: we've sent probes like Parker Solar Probe skimming closer to the sun than any spacecraft before, flying through the corona itself to taste its searing plasma. Yet, even with this data, the heating mechanism remains elusive, hiding in the chaotic interplay of magnetic fields and particles too small for our telescopes to spot. Solving this puzzle wouldn't just satisfy scientific curiosity, it would help predict solar storms that threaten satellites and power grids, and even reveal how other stars cook their own atmospheres. So next time you squint at the sun during an eclipse, remember, that delicate halo of light isn't just pretty, it's a million-degree enigma. A reminder that even the most familiar star in our sky still guards secrets hot enough to melt our assumptions. Imagine a storm so vast it shrouds an entire planet in a choking red haze for months, a tempest where winds hurl dust at hurricane speeds, blotting out the sun and turning day into perpetual twilight. This isn't science fiction, it's a regular event on Mars where global dust storms can engulf the entire planet, stretching from pole to pole and lasting for weeks or even months. These aren't just inconvenient weather patterns, they're planetary-scale catastrophes that reshape the Martian landscape and threaten every mission we send there. The most infamous of these storms struck in 2018, growing from a local squall into a global monster within weeks. NASA Opportunity rover, a resilient machine that had survived 14 years on Mars, suddenly found itself starved of sunlight. Solar panels that usually soaked up energy to keep the rover alive were coated in thick dust, plunging its systems into darkness. Despite desperate attempts to wake it, Opportunity fell silent forever, its final transmissions painting a grim picture of a sky so dark it seemed like midnight at noon. But the storms don't just kill robots, they rewrite the rules for future human explorers. Picture settlers huddled in habitats, watching as solar arrays that power their life support systems gradually dim under a blanket of dust. Backup generators might keep them alive, but resupply missions from Earth could be delayed or even grounded, as dust clouds interfere with landing systems and obscure visibility. The storms also trigger temperature swings so extreme they'd test even the sturdiest equipment. Surface temperatures can plummet or soar by dozens of degrees as dust traps or reflects heat in unpredictable ways. Yet these storms aren't just obstacles, they're clues to Mars' past. Scientists believe they might be linked to the planet's ancient climate cycles, when dust-laden winds could have scoured valleys or shaped dunes we see today. Some theories even suggest these storms play a role in Mars' lingering mystery, the sporadic plumes of methane that hint at hidden geology or just maybe microbial life. Dust particles high in the atmosphere might act as tiny chemical reactors, sparking reactions we don't yet understand. The rovers still ticking away on Mars, Curiosity and Perseverance, have front-row seats to these apocalyptic events. Unlike Opportunity, they're nuclear-powered, so dust storms are more of a spectacle than a death sentence. Their cameras have captured eerie time lapses of the sky darkening, dust devils dancing across craters, and even the faint glow of the sun reduced to a dim orange orb like a dying ember in a smoky sky. For colonists, surviving these storms will mean rethinking everything. Solar power alone won't cut it. Nuclear reactors or advanced batteries will be non-negotiable. Habitats will need airlocks rated for dust finer than talcum powder, and spacesuits might require built-in wipers to keep visors clear. But there's a silver lining. The very dust that chokes the air could become a resource. Martian soil is rich in iron oxide, and future settlers might harvest it for oxygen or even process it into building materials. So the next time you see Mars glowing red in the night sky, remember, it's not just a desert world. It's a planet where the sky itself can turn against you, where storms don't just pass but linger like ghosts, reshaping the future of exploration one grain of dust at a time. And as we plan to plant boots on that rusty soil, we're not just fighting gravity and distance, we're battling an entire world that seems determined to remind us, space never plays fair. Saturn's rings are the solar system's most dazzling accessory, a shimmering belt of ice and rock that makes the planet instantly recognizable. But here's the twist, those iconic rings might be younger than the dinosaurs. Recent data from Cassini's final orbits revealed a shocking truth. Saturn's rings likely formed just 100 to 200 million years ago, a blink in cosmic time. Picture a T-Rex gazing up at a naked Saturn, its night sky missing the jeweled crown we take for granted today. That's how recent this spectacle really is, and it raises a question even more fascinating than the rings themselves. How did they get there in the first place? The leading theory reads like a celestial demolition derby. A moon roughly the size of Mima's Saturn's crater-pocked Death Star satellite may have wandered too close to the planet, where tidal forces ripped it apart. Imagine a world cracking like an egg, its icy shell shattering into billions of fragments that slowly spread into the disks we see today. Others argue a passing comet could have been torn apart by Saturn's gravity, scattering debris in its wake. Either way, the math checks out. The rings are too pristine, too free of dust to have survived billions of years. Cosmic collisions and micrometeorite strikes should have darkened them over time, yet they gleam like fresh snow, proof they're newcomers on the planetary stage. But the real mystery lies in what these young rings tell us about Saturn's violent history. The planet boasts 62 moons, each with chaotic orbits that hint at past upheavals. Some, like tiny Pan, skate along the ring's edges, sculpting gaps as they go, while others, like Enceladus, spew geysers of water ice that might replenish the rings from within. It's a dynamic, ever-changing system where moons and rings are locked in a gravitational dance, constantly reshaping one another. Here's what's even wilder: Saturn's rings might be vanishing. Cassini measured ring rain, a phenomenon where charged particles spiral down into Saturn's atmosphere at a rate that could drain the rings entirely in another 300 million years. That means we're catching this cosmic masterpiece in its prime, a temporary wonder bookended by epochs of emptiness. Future astronomers might peer through telescopes to find a bare Saturn, wondering why ancient observers raved about rings they'll never see. So next time you spot Saturn through a telescope, remember, you're witnessing a fleeting moment in cosmic history, a spectacle that bloomed long after the dinosaurs faded, and one that could disappear before humanity does. Whether born from a moon's sacrifice or a comet's wreckage, these rings are a reminder. Even the grandest things in the universe are just passing whispers in the dark. Picture a world where daytime temperatures soar high enough to melt lead, where the sun blazes 11 times brighter than on Earth, and yet, hidden in the planet's darkest corners, ice lingers untouched. This isn't a sci-fi paradox. It's Mercury, the solar system's smallest planet, guarding frosty secrets in the unlikeliest of places. Deep within polar craters, some so deep sunlight has never reached their floors, temperatures plummet to -200 degrees Celsius, creating icy reservoirs that defy the inferno just beyond their shadows. How did water end up on a planet where surface temperatures swing between extremes fit for a forge and a freezer? The answer might lie in cosmic delivery trucks, asteroids, and comets. Over billions of years, these icy wanderers likely bombarded Mercury, leaving behind water molecules that migrated to the poles. With no atmosphere to disperse them, the molecules settled in permanently shadowed craters, frozen in place like relics in a cosmic vault. Radar scans from Earth first hinted at this glimmering treasure in the 1990s, and NASA Messenger probe later confirmed it, detecting bright patches consistent with water ice. But here's the twist: Mercury's ice isn't pure. Mixed with dark organic material, it's more like a dirty snowbank than a pristine glacier, possibly coated by comet dust or chemical reactions with the planet's surface. Some craters even host ice exposed directly to space, while others bury it beneath strange black layers scientists still struggle to explain. These shadowed traps aren't just geological oddities, they're time capsules preserving raw ingredients from the solar system's violent youth. For future explorers, these icy vaults could be game changers. Imagine landing a rover near Mercury's poles, where solar panels could soak up endless sunlight on crater rims while drills extract water just meters away in the darkness. That water could be split into hydrogen for fuel and oxygen for breathing, a ready-made gas station for deep space missions. Mercury's ice might one day serve as a pit stop for ships venturing farther into the solar system, turning this scorched world into an oasis in the void. Yet the real wonder isn't just the ice itself, it's what it tells us about resilience. In a universe full of extremes, water finds a way to endure, clinging to existence in the unlikeliest crevices. If ice can survive on Mercury, where else might it hide? The moon's shadowed pits, asteroid fissures. The answer could rewrite our understanding of where life might take root. So next time you think of Mercury as just a burnt cinder, remember, it's also a silent keeper of frost, a reminder that even in the harshest corners of the cosmos, nature always leaves a back door open. Out in the vast emptiness of space, an unexpected aroma lingers, the sweet, tangy scent of raspberries. Scientists probing the heart of the Milky Way's Sagittarius B2 nebula made a bizarre discovery: clouds of ethyl formate, the same organic compound that gives raspberries their unmistakable fragrance. That's right, if you could take a deep breath in the depths of that cosmic cloud, it might smell like a cosmic dessert buffet with a faint hint of rum lingering in the mix. Yes, ethyl formate is also responsible for the sharp, boozy aroma of distilled spirits. It's as if the universe bottled its own perfume, and the top notes are straight from a farmer's market. So how does a giant molecular cloud end up smelling like fruit? The answer lies in the chaotic kitchens of star formation. Ethyl formate forms when simple molecules like methanol and ethanol crash together in the frigid depths of space, helped along by radiation and dust grains acting as cosmic mixologists. These clouds, packed with complex organic molecules, are essentially ingredient factories for life's building blocks, proof that the universe has a sweet tooth long before planets or even stars take shape. And here's the kicker: comets might be the delivery drivers sprinkling these molecules across the cosmos. When these icy wanderers slam into young planets, they could be seeding them with the very compounds that eventually give rise to flavors, scents, and maybe even life itself. But don't go ordering a nebula-scented candle just yet. Sagittarius B2 isn't exactly a breezy meadow. It's a turbulent, radiation-blasted region where temperatures swing from near absolute zero to blistering highs. That raspberry whiff comes with a side of poisonous hydrogen, cyanide, and enough toxic gases to make one breath your last. Still, the fact that these delicate organic molecules survive at all in such a hostile environment hints at how tenacious chemistry can be. It's a reminder that the universe isn't just rocks and fire. It's a place where the building blocks of candy stores and cocktail bars are cooked up in the void, waiting to hitch a ride on the next passing comet. So next time you bite into a raspberry, think bigger. You're tasting a flavor the universe has been brewing for billions of years, a tiny echo of the cosmic kitchen where molecules dance in the dark. And who knows, maybe the scent of some alien fruit on a distant world shares the same chemical roots, proof that even in the infinite vastness of space, some things might smell strangely like home. Talk about a planet that defies every expectation. On Venus, time itself seems to operate backward. While Earth pirouettes through a 24-hour day, Venus drags out a single rotation over 243 Earth days, making its day actually longer than its entire year of 225 days. That means if you lived on Venus, which you couldn't, for countless reasons, you'd celebrate your birthday before you even finished a single sunrise to sunrise cycle. It's like watching a clock where the hour hand moves slower than the calendar pages flip. This bizarre reversal of cosmic logic happens because Venus spins at an agonizingly slow pace, creeping through one full rotation while completing a full lap around the sun in less time. Picture a figure skater spinning lazily on one foot while gliding in a wide circle, except the skater is a planet and that lazy spin takes actual Earth months. To make things even weirder, Venus rotates backward compared to almost every other planet in the solar system, meaning the sun rises in the west and sets in the east. If you could stand on its scorching surface, you'd witness a sunrise that takes weeks to crawl above the horizon before lingering for months, only to then set in equally sluggish motion. Why does Venus drag its feet like this? Scientists suspect a catastrophic collision billions of years ago might have knocked the planet into this slow-motion roll, or perhaps the thick, soupy atmosphere, so dense it behaves like liquid has been dragging against the planet's surface like an invisible hand pressing on a spinning top. Whatever the cause, the result is a world where the very concept of a day loses all meaning. A Venusian sunrise isn't a daily event. It's a rare celestial spectacle, like a solar eclipse on Earth, but stretched into an endless performance. This extreme rotation also means Venus has no real seasons. While Earth's tilted axis gives us summer and winter, Venus stands almost perfectly upright, its sluggish spin offering little variation in sunlight distribution. The planet's surface is uniformly hellish, a 900-degree Fahrenheit wasteland where lead flows like water and the air crushes with 90 times the pressure of Earth's. Forget weather forecasts. On Venus, the forecast is always the same. Blistering heat, acid clouds, and a sun that meanders across the sky like it's got all the time in the universe. Yet here's the twist: despite its marathon days, Venus' upper atmosphere screams along at hurricane speeds, circling the planet every 4 Earth days. Winds howl at 220 miles per hour, creating a super rotation that whips clouds around faster than the planet itself spins. So while the surface crawls, the sky races, making Venus a planet of contradictions. A place where time warps, where directions reverse, and where the rules we take for granted on Earth simply don't apply. For astronauts of the future, a Venusian workday would require serious adjustments. Forget 9 to 5, you'd need a calendar just to track when to wake up. And with the sun spending months in the sky before vanishing for another marathon night, circadian rhythms would be hopelessly scrambled. But for now, Venus remains a cosmic oddity, a reminder that even something as fundamental as a day can twist into strangeness when you step beyond our pale blue dot. Floating through the void like a ghostly leviathan, the Smith cloud stretches 11,000 light-years across a colossal wave of hydrogen gas barreling toward our galaxy at nearly 200 miles per second. Discovered in 1963 by astronomy student Gail Smith, this cosmic phantom weighs over 2 million suns and glows faintly in radio waves, a silent predator stalking the Milky Way's outer edges. But here's the twist: this isn't just any interstellar cloud. 30 million years from now, it's set to slam into our galaxy's spiral arm, triggering a celestial fireworks show that could ignite thousands of new stars or tear apart entire solar systems. What makes the Smith cloud so special? Unlike most drifting gas clouds, this one carries a chemical fingerprint proving it was born in the Milky Way. Analysis reveals heavy elements like sulfur, ingredients forged in stellar furnaces, meaning this behemoth was somehow ejected from our galaxy eons ago, only to boomerang back with a vengeance. Picture a cosmic breadcrumb trail. The cloud's elongated shape suggests it was stretched by the Milky Way's gravity during its outward journey, like taffy pulled between 2 hands. Now it's racing home at supersonic speeds, trailing a shimmering wake of ionized gas 6,500 light-years long. When this rogue wave crashes back into our galactic disk, the collision will be anything but gentle. The impact will compress hydrogen gas like a snowplow piling up drifts, creating pockets so dense they'll collapse under their own weight star nurseries where nuclear fusion ignites in spectacular bursts. Simulations show the Smith cloud could spawn over 2 million suns, lighting up the galaxy's fringes like a string of cosmic Christmas lights. But there's a darker side. Any planetary systems caught in the deluge could have their atmospheres stripped away by the incoming shockwaves, leaving barren rocks adrift in a sea of superheated gas. Yet the Smith cloud is more than just a future spectacle. It's a clue to one of astronomy's biggest mysteries: how galaxies grow. Most of the Milky Way's gas is locked up in stars, leaving little raw material for new ones. Clouds like this act as galactic reservoirs, recycling hydrogen expelled by dying stars back into the system. Without them, galaxies would starve, their star-forming factories grinding to a halt. The Smith cloud alone carries enough fuel to manufacture thousands of solar systems, proving the universe has a thrifty habit of reusing its building blocks. Here's what's truly mind-bending. We're witnessing this drama unfold in ultra-slow motion. 30 million years might sound like an eternity, but on cosmic timescales, it's a blink. By the time the Smith cloud makes landfall, Earth could be unrecognizable continents reshaped, species evolved or extinct, humanity itself possibly scattered among the stars. Yet the cloud will keep its date with destiny, indifferent to our fleeting existence. It's a reminder that the universe operates on its own clock, where even the grandest events unfold at a pace that dwarfs human imagination. So the next time you gaze at the Milky Way's shimmering band, remember, out there in the darkness, a silent titan is racing toward us, carrying both destruction and creation in its wake. The Smith cloud isn't just a space oddity, it's proof that even galaxies have lifespans shaped by collisions far beyond our control. And when it finally arrives, the night sky might just gain a few million new lights. Pluto wears its heart on its sleeve, or rather, its surface. The dwarf planet's most iconic feature, a sprawling, heart-shaped glacier named Sputnik Planitia, isn't just a cosmic valentine, it's a geological powerhouse that literally tipped Pluto on its side. Stretching over 600 miles wide, this basin of frozen nitrogen, methane, and carbon monoxide dominates one hemisphere like a glacial bullseye. Its smooth plains cracked into polygonal cells by the slow churn of convection currents. But here's the real kicker. This icy heart is so massive, it reshaped Pluto's entire orientation in space. How does a glacier rewrite a world's spin? It all comes down to weight. Sputnik Planitia is a colossal slab of ice up to 6 miles thick, packed with enough frozen nitrogen to outweigh a mountain range. When NASA's New Horizons probe zipped past in 2015, it revealed the basin sitting suspiciously aligned with Pluto's tidal axis, the line where its largest moon, Charon, exerts the most gravitational pull. Scientists realized this wasn't coincidence. The glacier's sheer mass acted like a counterweight, rolling Pluto until the heart settled opposite Charon in a gravitational tug of war. Imagine spinning a basketball on your finger, then slapping a lump of clay on one side. The ball would wobble until the heaviest part faced downward. Pluto did the same, reorienting itself to balance the load, a process called true polar wander. But the heart's influence doesn't stop there. Sputnik Planitia might be a frozen tomb for an ancient impact, a scar from when a space rock blasted a chunk of Pluto's crust into oblivion. Over eons, nitrogen snows seeped into the depression, building an ice sheet so thick it became a planetary keel. Today, the basin's surface resembles a cosmic beehive, its hexagon-patterned plains bubbling like a pot of simmering syrup as warmth from Pluto's interior pushes ice upward, only for it to cool and sink again in a slow-motion dance. What's truly mind-blowing, this glacier might hide an ocean. The heart's alignment suggests Pluto's crust is thinner beneath it, cracked by the long-ago impact. Combined with hints of recent tectonic activity, some researchers think a subsurface sea of slushy water could lurk below, kept liquid by radioactive decay and tidal squeezing from Charon. If true, Sputnik Planitia isn't just reshaping Pluto's surface, it's guarding secrets that blur the line between frozen rock and potential haven for chemistry we don't yet understand. So next time you see that heart-shaped glow in Pluto's photos, remember, it's not just a pretty landmark, it's a world wrecker, a spin flipper, and maybe even a lid hiding something far stranger beneath. And for a tiny world at the solar system's edge, that's one big personality packed into a single, icy Valentine. Imagine reaching out and touching a star, not a metaphor, but actual contact with a celestial body glowing faintly in the void. Meet the Y-class brown dwarfs, cosmic oddballs so surprisingly lukewarm you could theoretically rest your hand on their surfaces without burning to a crisp. These failed stars, some chilling at a mere 80 degrees Fahrenheit, defy everything we assume about stellar furnaces. While their bigger siblings blaze at tens of thousands of degrees, these misfits hover at temperatures you'd expect on a mild spring day, emitting a dim reddish glow barely visible against the black of space. What makes these stars so bizarrely cool? Brown dwarfs occupy the murky gap between planets and true stars, too small to ignite sustained hydrogen fusion in their cores, but too massive to be dismissed as mere gas giants. The Y-class ones are the coldest of the bunch, some barely hotter than Jupiter. Without the nuclear fires that power sun-like stars, they radiate only residual heat left over from their formation, slowly fading like dying embers. The coldest known, WISE 0855, registers a frosty -10 degrees Fahrenheit colder than a winter night in Antarctica. The contrast with their stellar cousins couldn't be sharper. Blue hypergiants like Eta Carinii burn at over 40,000 degrees. Their surfaces so viciously hot they blast away their own outer layers in violent eruptions. But why dwarfs? They're the cosmic equivalent of a smoldering campfire, their atmospheres thick with methane and water vapor, more akin to Jupiter's stormy skies than the seething plasma of a main sequence star. If you stood on a hypothetical planet orbiting one, the sun in your sky would be a dim cherry-colored orb, casting shadows weaker than those from a full moon on Earth. Yet these lukewarm dwarfs play a crucial role in the stellar family tree. They're celestial missing links, helping astronomers understand how gas giants transition to full-fledged stars. Some might even harbor exotic weather patterns, clouds of molten iron or sand like silicate particles raining through alien atmospheres. And because they're so faint, they're devilishly hard to spot. Most are discovered by their feeble heat signatures in infrared telescopes like the James Webb. So while we marvel at the brilliance of blue giants and the steady glow of yellow suns, let's save some awe for these quiet, shadowy stars, proof that the universe crafts its wonders in every temperature range. From infernos to iceboxes, the cosmos refuses to be boxed into expectations, offering a stellar spectrum as diverse as it is dazzling. Hidden beneath the Milky Way's glittering spiral arms lies a ghostly skeleton, a network of dusty filaments so vast it weaves through our entire galaxy like cosmic connective tissue. These are the bones of the Milky Way, colossal strands of gas and dust stretching thousands of light years, invisible to the naked eye but glowing faintly in infrared light. Thanks to telescopes like NASA, Spitzer, and ESA's Herschel, we've begun mapping this intricate web, revealing a hidden architecture that holds our galaxy together. Picture the Milky Way not just as a flat disk of stars, but as a living entity with its own nervous system, threads of raw material pulsing with the potential to birth entire star clusters. These filaments aren't just passive decorations, they're stellar nurseries on a galactic scale. Gravity tugs at the densest knots within these dusty tendrils, collapsing them into protostars like pearls strung along an invisible necklace. Some, like the famous Bone Digger filament in the Orion Molecular Cloud Complex, stretch over 500 light-years and bristle with newborn stars. Others, like the gossamer threads in the Good Belt, form sweeping arcs that may trace ancient supernova shockwaves, echoes of long-dead stars sculpting the galaxy's next generation. It's as if the Milky Way grows its own stars on a scaffold, knitting new suns into being along the celestial spine. What's startling is how much these structures resemble biological networks. The largest filaments branch like fractal neurons, with smaller tributaries splitting off to feed star-forming regions. Some twist into helical shapes, suggesting magnetic fields acting as cosmic puppet strings, guiding the flow of material. And just as bones in a skeleton adapt to stress, these filaments respond to the galaxy's turbulence, snapping, merging, or even vibrating like plucked guitar strings when disturbed by nearby supernova or black hole activity. Yet the Milky Way's skeleton is more than just a static blueprint. It's a dynamic highway system for heavy elements forged in stellar hearts. When massive stars die, they spew iron, carbon, and oxygen into these filaments, enriching future stars and planets with the ingredients for life. Our own solar system likely formed in the shadow of such a structure, its chemistry shaped by the dusty ribs of a galactic skeleton we're only now learning to see. So next time you gaze at the Milky Way's hazy band arching across the night sky, remember, you're not just looking at stars, you're glimpsing the hidden scaffolding that built them, a vast, whispering framework where the galaxy's past and future quietly intertwine. Most planets lean a little. Earth tilts at 23 degrees, Mars at 25, but Uranus takes cosmic rebellion to the next level. This ice giant doesn't just tilt, it practically rolls around the sun like a wayward barrel, spinning on its side at a jaw-dropping 98-degree angle. Picture a top spinning sideways as it orbits. That's Uranus, with its poles alternately basking in decades of unbroken sunlight or plunging into equally long, frigid darkness. This isn't just a quirky pose, it's a planetary identity crisis that reshapes everything from its weather to its very concept of time. The leading theory for this extreme tilt reads like a cosmic crime scene. Billions of years ago, a rogue object, possibly an Earth-sized protoplanet, slammed into Uranus with such force it knocked the world off its axis. Unlike the glancing blow that gave Earth its moon, this was a full-on T-bone collision, sending Uranus into a gravitational tumble that never corrected itself. Evidence lurks in the planet's bizarre magnetic field, which skews at a 60-degree angle from its rotational axis, as if the entire planet's internal compass got scrambled in the aftermath. Even Uranus rings and moons orbit around its tilted equator, like a bullseye painted on the side of a rolling wheel. But the real drama unfolds with Uranus seasons, slow, grinding extremes that make Earth's winters look like brief inconveniences. Each pole gets 42 straight years of sunlight, followed by 42 years of unrelenting night. During the summer solstice at a pole, the sun circles directly overhead for decades, never dipping below the horizon. Then, as Uranus continues its 84-year orbit, that same pole gradually spirals into darkness, where temperatures plunge to -370 degrees Fahrenheit, cold enough to freeze the scant atmosphere into a crystalline haze. For hypothetical explorers, the view would defy all logic. Standing at the summer pole, the sun would scribe tiny circles in the sky, a perpetual noon with no sunrise or sunset. At the equator, daylight would race across the sky in just 17 hours. Uranus' short day, despite its marathon year, with the sun dipping bizarrely close to the horizon before vaulting upward again. And during the equinoxes, when sunlight strikes the equator head-on, Uranus rings cast a slender shadow across the planet, a fleeting eclipse visible only once every 42 years. Yet Uranus' tilt does more than create weird skies. It rewrites the rules for atmospheric dynamics. Most planets have jet streams aligned with their rotation, but Uranus' sideways spin twists its weather into chaotic spirals. When Voyager 2 flew by in 1986, it spotted a bland blue-green disk, but modern telescopes reveal explosive storms erupting as sunlight finally reaches long frozen polar regions, thawing layers of methane ice into swirling tempests. It's a world where summer doesn't just bring warmth, it detonates planetary-scale climate bombs. Here's the kicker: Uranus might not be alone in its tipped-over state. Exoplanet studies suggest oblique angles could be common in icy giants, especially those jostled by migrating planets in young star systems. But for now, Uranus stands as our solar system's ultimate oddball, a cautionary tale of celestial violence frozen in time. Its tilt isn't just a fun fact, it's a lesson in how one catastrophic moment can redefine a world forever, leaving a planet that doesn't so much orbit as it does wobble drunkenly through the cosmos. Galaxies aren't immortal. Scattered across the cosmos lie the husks of once vibrant star cities, massive islands of billions of stars that, for reasons we're still piecing together, simply stopped creating new ones. Astronomers call them red and dead galaxies, not because they're lifeless in the biological sense, but because their stellar assembly lines shut down long ago, leaving behind aging populations of crimson suns with no young, blue stars left to balance the palette. These cosmic retirement homes silently drift through space, their light slowly dimming as the last surviving stars burn through their fuel, the most famous of these galactic graveyards. The giant ellipticals at the hearts of galaxy clusters. Unlike our Milky Way, which churns out a modest 7 new stars per year, these behemoths haven't forged a single newborn sun in over 10 billion years. Their spiral arms, if they ever had them, have long since smoothed into featureless blobs, leaving behind a monotonous sea of old, cool stars. Hubble images reveal their eerie uniformity. No glittering star-forming nebulae, no blazing blue supergiants, just the dull glow of countless red dwarfs and dying giants. So what kills a galaxy? The leading suspect is something called quenching, a brutal cosmic drought where the gas needed to make new stars gets cut off. In dense galaxy clusters, the space between galaxies isn't empty. It's filled with scorching hot plasma that acts like a blowtorch, stripping incoming gas clouds before they can reach a galaxy's core. Imagine a farmer's irrigation pipe suddenly bursting. No water means no crops, and for galaxies, no gas means no stars. Some ellipticals might have quenched themselves by burning through their fuel too fast during wild youth-soft frenzied star formation, like cosmic spendthrifts exhausting their inheritance. But there's a darker possibility, supermassive black holes playing galactic Grim Reaper. At the center of every massive galaxy lurks one of these monsters, and when they feed, they don't just swallow matter, they belch out enough energy to sterilize entire galaxies. Jets of plasma screaming from the poles of active black holes can heat surrounding gas to millions of degrees, pushing it beyond the galaxy's gravitational grasp. It's like a volcano erupting beneath a fertile valley, leaving behind a barren wasteland. Observations of distant quasars, young galaxies with hyperactive black holes, show this might be a universal phase. The very engines that once powered these galaxies could have also signed their death warrants. Yet, dead doesn't always mean done. Some of these galaxies might be hiding reservoirs of cold gas in their outer halos, trapped like ice cubes in a desert, waiting for some future collision or cosmic event to jump-start their engines again. Others could be subtly cannibalizing smaller neighbors, stealing their gas like interstellar vampires to fuel a late-life comeback. And in the deepest voids, isolated red galaxies might be nursing secret stashes of gas too diffused to form stars yet. The eerie beauty of these galaxies lies in their silence. While the Milky Way thunders with supernova and stellar nurseries, these relics whisper of a time when the universe was younger, hotter, and far more chaotic. They're the cosmic equivalent of ancient ruins, monuments to an era when star formation wasn't a choice, but a battlefield where black holes, gravity, and sheer chance decided which galaxies thrived and which became mausoleums. And as we look deeper into space and further back in time, we're beginning to realize that death might just be another phase in a galaxy's life, not the end. Earth isn't as lonely as it seems. Tucked within our planet's gravitational embrace drifts a mysterious cosmic companion called Camoolwa, a tiny asteroid that dances with Earth in an elegant celestial waltz. Discovered in 2016, this 50-meter-wide space rock orbits the Sun in perfect sync with our planet, matching Earth's yearly rhythm so precisely it appears to loop around us like a miniature moon. But here's the twist: Camolwa isn't bound to Earth's gravity like our proper moon. Instead, it's what astronomers call a quasi-moon, a temporary tag-along locked in an orbital resonance that makes it Earth's shadow partner for centuries before it inevitably drifts away. What makes this cosmic hitchhiker so fascinating? Its origins are shrouded in mystery. Some scientists argue Camolwa could be a fragment of our actual moon, blasted into space during an ancient asteroid impact. Spectral analysis reveals its surface reflects light similarly to lunar rocks, sparking theories it might be a piece of the moon's crust that escaped Earth's gravity long ago. Others propose it's just a random near-Earth asteroid that fell into this peculiar orbital ballet, a chance alignment that could last another 300 years before the sun's gravity reshuffles the celestial deck. The quasi-moon's path is an intricate cosmic figure 8 when viewed from Earth's perspective, weaving inside and outside our planet's orbit like a roller coaster with the sun as its track. At its closest, Camolwa drifts about 9 million miles away, 38 times farther than the real moon, yet its synchronized motion makes it seem like a loyal companion. Unlike traditional moons which orbit their planets directly, quasi-moons are really orbiting the sun, just in a pattern so harmonious with Earth's movement they appear tethered to us. But Camolwa's time as Earth's cosmic dance partner is fleeting. Computer simulations suggest its current orbit is unstable, a temporary arrangement sculpted by gravitational chance. In a few centuries, perturbations from other planets, especially Venus, will likely disrupt this delicate balance, sending the asteroid spiraling into a new trajectory. That transience makes it a precious target for study. China's Tianwen-2 mission plans to visit Camolwa in 2025, potentially returning samples that could finally solve the riddle of whether it's a lost piece of the moon or just a sun-orbiting stranger passing through. For now, this cosmic interloper offers a humbling reminder. Even Earth's neighborhood isn't static. Moons can be temporary, orbits are ever-shifting, and sometimes the universe grants us fleeting companions just to show how dynamic the dance of gravity truly is. So the next time you gaze at the moon, remember, it might not be the only one watching over us. A shy, wobbling cousin could be tracing silent circles in the deep, a ghostly echo of our planet's gravitational pull. Black holes aren't silent predators, they're celestial composers, humming deep space melodies that reverberate across the cosmos. Take the supermassive monster at the heart of the Perseus galaxy cluster, 250 million light-years away. For decades, astronomers knew this black hole was creating ripples in the hot gas surrounding it. But it wasn't until NASA's Chandra X-ray Observatory analyzed the data that they made an astonishing discovery. Those ripples were sound waves, a low-frequency hum echoing through intergalactic space like a cosmic bass note held for eternity. Here's how it works. As the black hole devours matter, it doesn't just swallow material quietly. It belches out enormous jets of energy that slam into surrounding gas clouds. These violent outbursts create pressure waves like the shock wave from a bomb blast, except instead of dissipating, they travel outward in perfectly spaced ripples. The pitch of this sound is determined by the distance between those ripples and the speed at which they're moving. But there's a catch. The natural frequency of this black hole's voice is a staggering 57 octaves below middle C, a note far too deep for human ears to hear. To make it audible, scientists had to transpose the waves up by quadrillions of times, revealing an eerie, ghostly tone that sounds less like music and more like the moan of a haunted interstellar abyss. What does this tell us? For one, black holes aren't just destroyers, they're sculptors, shaping their environments in ways we're only beginning to understand. Those sound waves carry enough energy to heat the surrounding gas, preventing it from cooling and collapsing into new stars. In a way, the black hole's song might be suppressing entire generations of stars from ever being born, its voice a lullaby that keeps the galaxy in a strange, heated stasis. But the Perseus black hole isn't the only cosmic musician. Other supermassive black holes show similar pressure ripples, each with their own distinct pitch based on their size and feeding habits. Some might produce deeper drones, while others could generate higher frequency pulses, a celestial orchestra where every performer sings in a different key. The Milky Way's own supermassive black hole, Sagittarius A, is likely humming its own quiet tune, though we haven't yet tuned our instruments to hear it clearly. So the next time you think of black holes as bottomless pits of darkness, remember, they are also the universe's most unexpected choir, broadcasting their presence not through light, but through vibrations that shake the fabric of space itself. And while we may never stand close enough to hear them unaided, their songs ripple onward, a reminder that even the most destructive forces in existence can still create something strangely, hauntingly beautiful. We think of the moon as a silent, lifeless world, a frozen desert where nothing moves but shadows. Yet beneath its dusty surface, our lunar neighbor hides a secret it shakes. Moonquakes rumble through the moon's crust with the same unpredictability as earthquakes, but their origins are far stranger. Some are triggered by the same gravitational tug of war that creates Earth's ocean tides as our planet's pull stretches and squeezes the moon like a cosmic stress ball. Others come from the moon's crust itself, cracking like an overbaked cake as it cools in the vacuum of space. These tremors aren't rare. Apollo astronauts left seismometers that recorded thousands of them, some lasting over 10 minutes, their vibrations echoing through the moon's dry, brittle rock like a struck bell. What makes moonquakes so different from the quakes we know? Without water or tectonic plates to soften the blows, seismic waves travel farther and faster, reverberating through the moon's rigid interior with eerie efficiency. The strongest moonquakes can reach magnitudes up to 5.5, enough to topple structures not built to withstand them. And while most are deep below the surface, shallow tremors near the moon's scarce fault lines could pose real risks for future colonies. Imagine setting up a lunar base, only to have its fragile habitat walls shudder as the ground beneath it splits without warning. The moon's lack of atmosphere means there's no whether to erode its cliffs or soften its slopes, leaving unstable terrain that moonquakes could trigger into sudden landslides. The Apollo missions gave us our first glimpse of this hidden lunar violence, but the data they collected was limited, just a handful of stations working for a few years. Modern scientists are desperate for updated readings, especially as nations race to establish permanent outposts. New seismometers could map the moon's underground fractures like cosmic ultrasound, helping settlers avoid danger zones. Some proposals even suggest using moonquakes to peer deep into the moon's core, analyzing how seismic waves bend to reveal whether it still holds a molten heart or has cooled to a solid husk. Yet the most startling discovery might be how alive the moon still is. Thermal quakes caused by the brutal temperature swings between lunar day and night prove its surface is still adjusting, still settling, even after 4.5 billion years. Craters we see as static scars might actually be creeping, their walls sliding millimeter by millimeter as moonquakes nudge them. Future explorers could wake to find fresh cracks in the regolith outside their airlocks, evidence that the moon isn't just a rock to be conquered, but a dynamic world with its own geological grudges. So while we dream of lunar cities and off-world mining, the moon whispers a warning in tremors and shudders. Its silence was never a promise of safety. Every quake is a reminder that even the closest world to Earth plays by rules we're only beginning to understand. And for those brave enough to live there, listening to the moon's vibrations won't just be science, it'll be survival. From diamond planets where gemstones rain from the sky to black holes humming deep cosmic melodies, the universe has proven itself stranger than any classroom could have prepared us for. Who would have guessed that a world like 55 Cancri E could exist, a scorching wasteland with a core of solid diamond bigger than Earth? Or that the void itself carries the scent of raspberries, thanks to vast clouds of organic molecules drifting between the stars. And let's not forget Neptune, a planet that burns hotter than it should, defying logic as it showers its own core with diamond rain. These aren't just fun facts, they're reminders that reality will always outshine our wildest imaginations. But here's the real kicker: we've barely scratched the surface. Every discovery peels back another layer of cosmic mystery, revealing new questions we didn't even know to ask. Did the fact about the moon's slow escape surprise you? Or was it the revelation that Pluto's heart-shaped glacier literally tipped the dwarf planet on its side? Maybe you're still wrapping your head around the Smith cloud, a hydrogen leviathan racing toward our galaxy to ignite millions of new stars. Whatever stood out, one thing's clear: space refuses to play by the rules we try to assign it. So here's your cosmic call to action: keep exploring. The universe is weirder, wilder, and more wonderful than any textbook could capture. And every new observation, every mission, every breakthrough adds another piece to the puzzle. Hit subscribe to join us as we dive deeper into the cosmos, because the next jaw-dropping revelation is always just over the horizon. And who knows, the next time you look up at the night sky, you might just spot a world, a phenomenon, or a story that reshapes how you see everything. The universe didn't come with a manual, so let's unravel its secrets together.